Okay, you should have your quizzes back, and I just want to go over a couple things with you about some corrections that maybe not everybody in class understood, like the problems I took off the most frequently on. So I'm going to assume everybody can find someone in the room on the front page to kind of show what they needed to do there. Going on to the second page, I did want to go over question number 3. So your graph should look like that. Most of you graphed it fine. Please make sure that your holes are obvious, though. And I did ask that you label your tick marks, which I didn't really take off for probably as much as I could have. But anyway, some of us are just making random tick marks but not showing what they are. So just be aware of that. And the holes have to be on both parts of the graph. Okay, the thing I took off for it was this, where it says use a table to justify your answer. If you're going to use a table to do these, first of all, if you don't have a table for these, you couldn't get any credit for that. Second of all, the x values in your table have to be approaching -3 from the left side, and they have to be approaching -3 on the right side. So I needed to see these specific values in your table. Now I know that the y values aren't very exciting, right? Here they're all -1, and over here they're all +1. But that is the expected x values that would provide the answer for the limit. So that's why we need to see those. You can't just pick any old integers on either side. Okay, the tax question is the next one. Ding, ding, ding. And I want to go over this one, number 5. It says a country taxes the first $20,000 of an individual's income at a rate of 15%. Okay, so most of you, if you just look at this piecewise function, this would describe that situation. If you make less than or equal to $20,000, the government or whoever collects the taxes in this country is going to take 15% of your income. Okay? It says all additional income over $20,000 is taxed at 20%. So the parts that most of us got correct are those 3 pieces. Okay? Making sure the domain is split up correctly. And then the hardest part was coming up with this limit. So what I have over here is I want you to think about, what if you made $80,000? What would you have to contribute for taxes this year? So the $20,000 of that is going to be taxed at 15%. And then $60,000, the remainder is going to be taxed at 20%, right? And this is where the variation comes in. This is where the variable lies, right? Because if I make $100,000, I'm going to have a split where I tax $20,000 at 15%, and then I'm going to tax $80,000, right, at 20%. So that's where the variation comes from. That's the role that X is going to play, the different incomes. So I have to show something. Well, it turns out no matter what, right, I'm always contributing this amount. This is $3,000, okay, if I actually multiply that. If you make more than $20,000, this country is going to always take $3,000 of it for sure. So I'm going to do $3,000 plus, and then we have to come up with a mathematical expression that will show me how I determine what amount to tax at 20%, right? Because I have to add that in here, okay? Well, how do I get $60,000 if my input is $80,000, right? How do I get $80,000 if my input or my income is $100,000? Okay, obviously that is from a simple subtraction. Take your income, subtract out $20,000, and that's the expression that you will need, okay, in order to figure out anybody's tax payment that they have to make, okay? And so it turns out for this that the limit does exist. These 2 pieces do connect, okay, and they just have a little bit different slope. This one's a little bit steeper. Okay, and just one thing here, when it asks if the limit exists, don't say things like, oh, my fingers came together, and yes, that's why the limit exists. On a couple of your papers, right, I had to make a note that it's not that your fingers come together, it's that the limit from the left and the limit from the right are the same, and that is really important, okay? All right, last ones are on the back, okay? If you caught this yesterday, I decided I did not grade the back at all because, quite frankly, I forgot that these limits that were on this quiz had kind of arguments in here that we didn't really go over. So I'm going to show you how to do number 6, and then if we need to go over number 7, we can. But really, here's the big problem. Okay, I didn't grade everyone's, but I glanced at a couple people's problems. You guys seem to think that if you have an expression such as this, that you can just write it this way. Limit as x approaches 0 of 6/5 times sine of x over x. And no one ever in the history of your mathematics career told you that it was okay to just pull this 6 out of the argument. That is insane. Okay, so these two things are not equal. So that's the first rule that most of you disobeyed. Okay, you can't just pull out things from sine's argument just because it looks nice. Okay, the way that you would actually prove this limit is to put additional things into the problem. Okay, so for example, we know that I would like this, what's in front of the x, to agree with the argument of sine, right? And so if I manipulate it this way and I put the 1/5 over here, what am I lacking, right? I'm just lacking a 6 here. So the way that I actually solve this is to multiply this limit by 6 over 6, okay? And then what I can do is I can reorganize some of this information. So this 6 doesn't matter, right? I mean, I guess I could write it next to here, but really I need this 6 down here. So an equivalent version of this would be to write 6/5, combining this 6 and that 5, times sine of 6x over 6x, right? So I've taken that 6/6, which is of course equivalent to 1, and then I've just reorganized it in a way that's going to help it make better. Help it make more sense. So then I would take the limits individually so you can show that work, and you would essentially have 6/5 times 1, and that is why the limit is 6/5. Okay? Okay, the last one down here, just these limits. Again, I think that there are people in the room that can do this, but when I graph this, right, my eye is drawn to this point at 2, 2. So that's the first thing I'm going to do is go ahead and plot 2, 2, okay, and kind of check that off my list. And then greater than 2, right, I'm going to go ahead and figure out what this is. So I have an open hole, right, because I have no equal to. If I plug in 2 here, I get 1 minus 1. So it's actually at 2, 0 where I have a hole. And then I have a slope of 1/2 to the right of 2. So I'm going to go up and, oh my god, this is so hard, up and over to 1/2. Okay, so that's my slope. And then x squared minus 4, of course, has a 0 at 2. Its vertex is down at 0, -4. So I'd put this point here. I know I have another point over here. And I have this parabola, right, attached to that. So this is what your graph should look like. Now I can look at the limit here in this picture. At 0, my limit should be -4. Okay? If I look at the limit at 2, we just need to verify that everyone understands that my fingers do approach the same y value, and that is 0. And then this is simply, remember that you can split up this, these operations as much as you like. You can take the limit as x approaches -1, 4 times the limit as x approaches -1 of f of x, plus the limit as x approaches negative. Now this is a little bit annoying, right? But this would be a different way to do it. But mainly, right, the whole thing you're missing here is this, the limit at -1. And so if I plug -1 into my parabola, you know, you probably don't want to read it off the graph. You probably want to look up here, and you get 1 minus 4 is -3. So I have 4 times -3 plus 1, and that's how I get my answer of -11. Okay? All right. Happy correcting and reflecting.